Hello, 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 hello. Hi guys, good morning. I hope everything is audible and visible. Whosoever is here, can you please write down? Yeah, today's contest was a nightmare. Nightmare. Like legit, it was a lot hard in comparison to the normal contest. Just let me know, whosoever is here, and I'm just trying, yeah, whosoever is here, and what all you guys tried everything. Just hi, hello, hi Sarthak, good morning. Hi Aditya, good morning. Let me quickly open the chat also here itself. Sorry, a bit late, for sure. Although question number 4 was, like, you can say it was not hard, not easy, but it was extremely difficult to come on to. As soon as you come on to implementation, maybe or maybe not hard, depending upon if you have solved inverse model questions previously, or maybe factorial or binomial, like NCR questions previously. But today's contest was very tricky. Like, even considering question number 2, it was also tricky. But yeah, just let me know. Hi Sarthak, 1/4. Yeah, like that is okay, because today's contest was actually very tricky. But yeah, whosoever other folks are here, just quickly write down below. We will start off with the questions in just a minute, and like just a minute, yeah. And yeah, for sure, for question number 3 and 4, I have not written the code, so we'll write the code together also. For question 1 and 2 also we can write, but yeah, for question 3 and 4 I have not written that, but so we can write that together and see how the mistakes goes. Cool. Any other folks who are here, regular ones? If yes, then can you please smash that like baby? That would be great. I'll also open here itself, because it's very hard for me to view, so it's good if I here also just like. And yeah, Abhay Thakur, 2 out of 4 done. Great, Abhay. And anyone else, like what you tried for question number 2, 3, 4. I just want to know that how far you guys reached on question number 2, 3 and 4. Cool. So we'll not waste any time and we'll start off, because it has been 12:05, 12:06. But yeah, if the regular folks are watching, can we please smash that like baby? Let's quickly start off with question number 1. Find the peaks. Very easy problem. You are given an array, 0 indexed integer array mountains. Your task is to find all the peaks in the mountain array. Return the array that consists of indices of peaks in the given array in any order. Now, what the peak defines, what their peak is defined is as a peak is defined as an element that is strictly greater than its neighboring elements. So we can just say one thing, that if we have something as, like, we know what's a neighboring element, right? We have element 0, 1, 2, 3, 4, 5, like these are the indexes. So we will start off with the first index, because it is said specifically that you have to start off with these indexes. As you can see, the mountain length is from 3 to 100, and you have to start off with the non-edge indexes. The first and last elements of the array are not as peak, so you for sure will start off with the mid indexes. So you can try for all these indexes. Now at this index, which is let's say my array name is ARR, AR of ID, I'll just check if it is more than AR of ID minus 1 and also AR of ID plus 1. If it is more than ARR of ID minus 1, and also it should be more than ARR of ID plus 1. If that is the case, I can simply say that that specific index is a peak index, and I can just simply push that index in my answer vector and simply return that answer vector. Cool. Cool. So we'll just quickly jump on and see how we can code this up. It's pretty easy. I modified this mountains array to my ARR array, and okay, like we can also code this, but that's pretty simple. If let's see, if you want to still code, then what we can do in here is that we know that we'll start off. Firstly, we can just have the answer dot size, or if you don't want, it's still okay. Now we can just start off with our index 1, as we said previously also, and we'll just go up till n minus 1 and not up till, which means like less than n minus 1, which is up till index n minus 2. Now with this, I'll just simply have a check that ARR of I should be more than my ARR of I minus 1, and also same ARR of I should be more than ARR of I plus 1. If that is the case, I'll simply push back this specific index in my answer, or what we have to push back index, right? So we'll just push back the index in our answer, which is I, and we can simply return the answer. So with this, you should be Swapnil, Ram Sarji, Ram Swapnil, and yeah, whosoever folks are like regular ones, because we just, okay, it's empty. ARR of I less than minus 1 and is less than this, answer pushback of I, and ARR of I is more than ARR of I plus 1, less, what we have to push back, ARR of I. I'm just going on to all the, sorry, I'm going on to all the indexes. I minus 1, I is I plus 1, and then I pushed back this specific index I. Okay, return the answer. Okay, sorry, return the answer. Okay, what's okay, empty, and 1 and 3 both are empty. Why? I just checked back vector answer int n. Oh, n is answer dot size, sorry, ARR dot size. Great. So what we will do is we can have this done. Cool. Now we'll quickly go on to question number 2. That was a bit tricky because I still remember, like, when I was solving it, the submissions for this question were pretty less. Around 500ish people only submitted, and that was quite a lot of time, as in this question was in comparison tricky in comparison to the standard questions of question number 2. So we'll quickly jump on to question number 2 and see what the question number 2 says for us. So it just says we have to find the minimum number of coins to be added. Now these are kind of the ad hoc problems. In this we have to build and find the patterns. So you'll see that how that can be done, but that is kind of progressive in nature. So there can be a chance that if you start off with this problem, it might take a while, but you might still reach to a solution, because it is just pattern recognition, kind of discovering of the patterns. Meanwhile, the folks are watching in, regular folks, can you please smash it like baby? That would be super great. And yeah, for sure, any questions, any doubts, anything whatsoever. Crack code size, yeah, that's true. Tripti, it's error size. I got great. Yeah, that's I have missed such kind of issues a lot. I just do something and I write it and I just try to figure out what's the issue. Cool. Minimum number of coins to be added. Now it just says that you are given a zero indexed integer array called as coins. Okay, we have the zero indexed integer array called as coins. Now representing the values of the coins available and integer array as target. So I have the coins array and I have the target. So these are the two things which I have in my like with us. Now an integer x is obtainable if there exists a subsequence of coins that sums to x. Simple that if I just say I want to obtain a target as 5, so I should be having some subsequence which should result me in a value of 5. That is one thing. Cool. Now return the minimum number of coins of any value that needs to be added to the array so that every integer in the array 1 to target is obtainable. Now my ultimate aim is I should be getting every element from one target, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. I should be able to achieve all these numbers. Now, is it possible? Yeah, it can be possible. Like considering what we can do is now an integer x is obtainable. Now as I said, it's a subsequent sum. I have to return the minimum number of coins of any value. Now I can add any value coin. I can add any value coin in this entire array of coins so that every integer in the array 1 to target is obtainable, which means let's say in this mid my 6 was not obtainable, so I can just do one thing. I can add a number 2, so I can just say that okay, 4 and 2 with this 6 is obtainable. So for sure I can add a number. Now your task is to add minimum number of coins. Again, value can be anything you can add, but you have to consider that you have to add minimum number of coins. Now, the first thing which comes in our mind is, while reading this kind of problem, is that we have this array which has these elements from 1 to 19. Now, with this 1 to 19 elements, your main task is to make all the elements, right? And you can make all the elements. So firstly, we'll make sure, okay, can I iterate on all the elements of target, or like should I figure out something else? That is one thing. So I saw my target is up till 1e5, which means I can iterate on all the elements of my target. Now what I can do is, now you know one thing, that you can now iterate on all the elements of target and try to build the target itself. Every element you will try to build. Now while building every element, you might think, bhaiya, so if I have to build a number, let's say 8, right? Would it not be good if I would have known if I can build a smaller number? Which means if I can build a number 7, I know I can simply add a 1 in it and I will be able to achieve 8. So, and it's a subsequent sum, right? So I cannot build a number 8 with the larger values. I cannot subtract, I can only add. So one thing also I got to know, that I can try building my target numbers in the increasing order, because if any smaller number is made, let's say 4 is made, let's say 1 is made, let's say 2 is made, I can add simply 4 and 2 to obtain a 6. So it is very well obvious that we will try to build or try to have the smaller number first. Maybe if that is not even possible to build, so maybe I will add that value coin. If that is not possible, and I'll add that value coin. Now with this, I will be having that value coin and I can use that smaller value coin to achieve a larger number. So other thing, like firstly we saw that we can iterate on all the elements of target. Next thing we saw that we will go on in the ascending order in the target itself, because it will help us to build the larger numbers. Now when this fact is done, now we will try to replicate the scenario of building the numbers. Now for sure I will start off with the 1. Now for sure 1 is the very small number. I cannot just simply add something with him. It needs to be there itself. So I'll just go and ask him, bro, do you have 1 with you? So I'll ask, bro, do you have 1 with you? Bro will say, yeah bro, I have 1 with me. Okay, cool. Now I will try to achieve my number 2. Now to achieve number 2, I don't have a number 2 with it. Can I make it? Like I don't have a number 2. So one thing is, like one option is directly which comes in our mind is add a 2. Or maybe if I can make a 2 with the existing sums. So firstly with the existing sums, which means any smaller value than 2. So I can only check for all the smaller values than 2. So one thing is obvious, that I will have to sort this down. I will have to sort my coins array also down, because I want all the smaller values than 2, which can actually help me build my 2 number. But then I saw I don't have a 2, I only have a 1. So now to build a 2, I can one option for me is I can add a coin of value 1 in this array. So you will see that you will obtain 2 coins of value 1, and with this coin which I add of value 1, I will obtain a 2 for sure. But that is not a progressive thinking. What if like your task is, again, as I mentioned, you can add any value coin. Here you added a value 1 coin, and with this for sure 1 plus 1 is 2. You will be able to achieve 2. But that is not a good strategy. Why? Because if you had added a 2 here, so with this 2 you can achieve a 2 for sure, because 2 is a value of 2. But with 2 and 1 you will be able to achieve a 3 also in future. So thinking of future, you will try to add a maximum value coin which you don't have. So that is one thing. That is the third thing which we figured out, that we will try to add a maximum value coin. So again, I did not have a 2 and there is no way I can make a 2. I'll simply add a 2 here. So 2 is one thing which I have to add. Now I went on to 3. Now 3, can I make a 3? Yeah, for sure I can make a 3. 1 and 2, I can make a 3. Oh yeah, great. But how would I even know that what all numbers I can make? Because in future I might line out with some next number. But yeah, with this, so far you know that you can make a 3. That is like, remember that you can make a 3. Okay, you go on to 4. Now, for sure, 4 you will land on to, and 4 you have a number. Great, bro. Move on. You went on to a 5. Can you make a 5? Yeah, for sure. 4 plus 1, 5 I can make. Yeah, for sure. Cool. Move ahead. Can I make a 6? 4 plus 2? Yeah, 6. I can also make a 6. Yeah, move ahead. Can I make a 7? 4 plus 2 plus 1? Yeah, I can make a 7. Cool. Move ahead. Can I make a 8? 4 plus 2 plus 1. Maximum I can make a 7. Just hold on. Right now you saw maximum you can make a 7. Just look back one thing. Now when I say maximum I can make a 7, you can also see you can make every number from 1 to 7. Agree on that part? You can make every number from 1 to 7 because you know for sure you have been making these numbers. So with this configuration of 1 to 4, you can make every number from 1 to 7. Just remember this part. You can make every number from 1 to 7, and that is you have been seeing so far also. Okay, 8 is something. I have a number 10 which is more for sure. I can make only up till the number 7, which means I have been kind of maintaining this particular sum. Just at the back of your mind you will see that because you were able to achieve a number 7, which was this. Now 8 was something which was not able to achieve, but yeah, let's say which was not able to achieve, so I'll just simply add a 8 here. Now hold on, you added 8. Okay, you added 8. Now 8 is done. Now I'll ask you, let's forget whatsoever is afterwards. Just let me know if you added a 8. If you added a 8, what all numbers are now possible for you to make? You can make a 9, 8 plus 1, right? You can make a 10, 8 plus 2. You can make a 11, 8 plus 2 plus 1. You can make a 12, 8 plus 4. You can make a 13, 8 plus 4 plus 1. You can make a 14, 8 plus 4 plus 2. You can make a 15, 8 plus 4 plus 8 plus 4 plus 2 plus 1. 8 plus 4 plus 2 plus 1. You can make a 15, which is 8 plus 4 plus 2 plus 1. That is the maximum sum. That is the maximum sum. So with this added 8, you don't have to worry for any number up till 15. Which is, with this added 8, you don't have to worry for any number up till 15. But for you, lucky you have to go up till 19. So what about 16? No worries, bro. At that moment my 10 was already there. So if I have a 10, what it means is with this added 8 you never have to worry for any number up till 15. With this added 10 you will never have to worry for any number up till 25. So that is how you can just easily maintain a prefix sum and just say, bro, I had an initial array as 1, 4 and 8. When I was here, I don't have to worry for any number up till 1, right? I wanted a 2. Bro, 2, 4. Okay, 4 is more than 2. I cannot achieve something like that. So what I would need is I would have to add a 2. Okay, I'll add a 2. Now my prefix sum has become a 3. I don't have to worry for any number up till 3. Cool. Now when 3 will come, 3 will actually be solved because I don't have to worry for any number which is up till 3. Now I'll reach on to a 4. Oh, 4 I wanted and 4 you are. Okay, that is good. But I'll add in my prefix sum. My prefix sum was 3 earlier. I add a 4, it will become a 7. So I don't have to worry for any number up till 7. I encounter a 5th. Go, ignore. 6, ignore. 7, ignore. But also, okay, you land onto a 8. 8 you don't have, and your maximum prefix sum is a number 7. So you will have to worry for 8, which means you have to add 8. Okay, I will add 8. But with this added 8, my answer will actually increase by, my prefix sum will increase by 15. So I don't have to worry for any number up till 15. Okay, 9, I don't have to worry. 10, don't have to worry. 11, no. 12, no. 13, no. 14, no. 15, no. 16, no. 17, no. 15, no. 16, you will have to start worrying. But while you were iterating on your target, you would have seen that the 10 element would have come in, which would have increased your prefix sum to 25. So you don't have to worry for any number up till 25, and your target is up till 19 itself. So 19, all done, well and good. You only had to add a 8 and a 2, and that's it. So it's just that go maintain some prefix sum, go and maintain a kind of a pattern that if you encounter that, what if you encounter that prefix sum value, so simply you can just ignore. if you encounter the element, which is this particular element like 10, my prefix sum is more, my prefix sum is more than the element, simply add that in the prefix sum, no worries. But if my prefix sum, as you saw, my prefix sum when it was number 7, it is less than my target which I wanted to achieve at this moment, so simply you have to add that value. So it's just that simply by this pattern. Now it's just a pattern recognition, it's not much of algorithm, something like that. So it's just that how you recognize the patterns itself. So so as you you can see itself, I just added my prefix sums. Now if you want, we can actually code this up also. So let's reset this. So what I did was, now one thing which I did wrong, as you can see, the target and coins are both within 1e5. So your prefix sum value can actually go like long, but I try to I always keep long, so no worries on that part. Now I'll just have a pref sum. So my pref sum will start off with something. I will have my coins. Dot size. Now as you saw that I have to, ultimately I will also have my answer, which is how many coins I will have to add. Now value is not something which is matter for us. I will go on to all of my target values. Now let's say that my target starts from t, t is less than equals to my target, and let's say t plus plus. Now at the initial target value, what you want, the main task is at the initial target value, what you want. You just want that this part should be there, or my prefix sum or this value should be there. So I'll just ask, I can have an ID with me which will iterate on my entire array. I'll just have that if my ID is less than n, because you know that you can only check for index when it's actually there, and my coins of that specific ID is actually, if it is more than what I wanted, if this value is more than what I wanted, okay, else if it is less than what I wanted. Now it is what I wanted right now. If it is what I wanted right now and my ID it's at 0, so you will see that it will land onto this number. So one thing is, now shall we add a prefix sum here or not? That is one part, but it is, the implementation is very much different, that how we achieve it. It can be still different of how I wrote the code previously also in the contest, but it can be now also different. But now my main target is I am at the coins of ID, and if that is more than my target, shall I check my prefix sum first? Which means if I have a prefix sum, I would not have to check for this value. But considering we are checking this value, let's see, if I am at ID, now if it is less than n, and I am checking that my current coins of ID, if it is more than my target, so I'll just have a quick check that my prefix sum, if it is more than what I had. So let's create a scenario of 1 4 10, like this same event. I had a 1, so if I had a 1, so I'll simply achieve a 1 which is, well, like not more than my target. So I can just simply say that else, let's go to else condition first. So with this condition, I'll just have that my coins of my specific ID is less than equals to my t. Now if it is the case, now what I can do is I can simply add in my prefix sum that specific coins of my ID itself. Now what if it is okay, it is not okay, then what? So I can just simply say that okay, so what I can do is I'll just first have a prefix sum check. But prefix sum can be, but the prefix sum can be more, like can be less, because you have not added any values in the prefix sum. So yeah, we will add the prefix sum when we encounter that specific coin. So okay, I just added that specific coin in my prefix sum, and I'll just check. How did I even write the code previously in the first attempt? Cool. We'll still figure out that we will just have a prefix sum which is less than equals to my coins of ID. Now this specific coins of ID will actually say that I have added in my prefix sum this coins of ID. Now if this specific coins of ID, if it is more than t, I can just increase my ID. I can start adding my prefix sum. I can say just currently add the specific target value to my answer itself. So what I'll do, I'll just add my prefix sum with the specific t value. Now my prefix sum has increased, so I use sorting. Yeah, sorting will for sure have to be done. Sort of coins dot size, sorry, sort of coins dot begin and coins dot end, that is for sure required. Now when this coins is sorted, we will have to go on and check for that specific ID if that prefix sum of t, please reduce your pace. Oh, my pace is already slow. Like this question I have done, but still what happened is really simple implementation. I don't know. Cool. We still solve it. Cool. We will have the ID if it is less than n, and the coins of that specific ID if it is more than my target. I'll just simply say that it is no more useful for me to stand onto this specific ID of coins, so I can just simply add that specific t in my prefix sums. And then what I will do is I can just increase my specific ID. Oh, I should not increase my ID itself here because I did not consume this specific ID, but I'm going on to all the IDs. Bro, I did it within 5 minutes because I have solved similar problem before. I also did it not 5 minutes but less than it. I can see my timings. How was that done? Yeah, it was around like less, like it was not 5, it was around 8ish minutes something. But yeah, that was much more faster than any problems, because it was kind of a good problem, I should say. Like it was actually kind of a good problem, I should say, but no worries. So how much time? It don't show the times. Mine is not exactly similar to the questions of patching array, Leetcode patching array. Yeah, that was true. So yeah, firstly we'll just make sure that if my ID is actually less than n, then I will have, if it's actually less than my time, then I can simply add that my prefix sum. Now if that is added in my prefix sum, I can just simply go on to the next specific ID itself. Yeah, should we have solved it before the idea? Sachin Thakur. Cool. So what we can do is we'll just simply add that prefix sum in our t, and we have increased the ID. Now if let's say if the value have been more, so I will add that specific t in my answer, and with this fact I am just saying that the value of that specific coins of ID was more, so I still have not gone to it. But before this, I'll just simply have a check if my prefix sum, if it is more than equals to what I wanted right now, which is t, so I can just simply continue. And if not, then I can simply add that specific t values in my prefix sum. Now if added that specific t value in my prefix sum, I'll say one thing, that I have consumed that value, so I should increase my answer because I've consumed that value, and ultimately we should return our answer. With this, what we are saying is that if our coins of ID is less than equal to t, the target, so I can just simply add that prefix in my target. I can simply try on for the next ID later on. But if the coins of ID, if it is more than my t, then I'll just check if the prefix sum is more than equal to my t. If that is that, okay, simply continue, because my prefix sum is already more. I don't want to indulge in any activities, else I will have to add that specific t. Like it just means that I will use this coin ID plus plus not needed, I guess, in the first. Let's see. I will use this coin. I'll use this coin to add in my array of coins. Now when this portion is done, I'll simply say that, okay, I have used a coin. I have used a coin. Now when this is also done, so with this we should be able to actually see if it is giving a correct answer or not. 2 1 2. Okay, something we did wrong. Let's see if our ID is less than n and coins of ID is less than equal to t. I'll simply have to add not coins of ID but coins of ID, because I have coins and not ITs. Now let's see. Why took time? Accepted. ID plus plus not needed, I guess, in the first if. Oh no, yes it is. Okay, let's quickly have a chat read. I don't like, I think it depends entirely on how you implement it. Usually these kind of questions, you just like what, sometimes I do it faster, sometimes it takes a lot of time, because you are just lost in if this condition, that condition, that condition, this condition, so on and so forth. But yeah, let's quickly have a chat read. We will have, and like any questions whatsoever you have, just write it down. Cool. Crack code size, I was thinking in terms of bits, like adding 2 4 8 16 would be always optimal bits. Okay, no, that would not work. Like not in form of bits, you can think, because what you think of a number, like it's not a binary representation of a number, let's say 19. You will have to achieve and add specifically on, because see, you can think of binary representation when you are specifically make sure that your coins array are just in the powers of 2 itself. Then you can just apply this approach which you have thought of. But now your coins array can have any number, it can be 3 also, it can be 5 also. So then your case would not work. Your case, Shashank, would work when your coins array are actually binary in number, like let's say 2 4 6 in this form. JE partner 1/4. Yeah, true. Like today's contest was actually pretty tough. Like question 2 was also, like when I solved it was around 500 submissions only, and that was also like when I did one wrong submission because of some TL issues. Sorry, this integer overflow issue. I did not look for that long. This question isn't much intuitive. We need to have prior solved it before the interview. I don't think so. Like or like generally intuition works at the back of your head. I did not know any previous problem like this before. Maybe I have solved it, but maybe I have forgotten that, so I just actually tried out multiple stuff that worked. I just wrote it down. ID plus plus needed when the coins is less than equal to t. That's true. Thank you so much, tag. Bro, I did it define because I have solved similar problems. It is exactly similar to questions. Patching array Leetcode. Let's see. Patching array Leetcode. That's great, because that's great if you guys remember the problems itself. Oh, that's a hard question. It has been asked by Flipkart recently. Given a sorted array of nums and integer n, add patch elements to the array such that any number in the range of 1 to n inclusive can be found by the sum of some elements in the array. Return the minimum number of patches required. Oh, that's the exact same problem. That's great, Shashank. Like that's the exact same problem. Let's see if we can submit the same code. We will use this code. Let's see Firstly, we'll just have this hash defined. Now we will have minimum patch array nums coins and target, which is n. Okay, so we can just have this pasted. Control X, Control V, and just replace this. Now, okay, replace this coin. Sorry. Okay. Oh, yeah, mine is saved. So I will have to find how to replace this. Find and replace. I'll replace coins by nums, and also my target by n. And let's see if this works. Answer int n. Okay, I have this n. Is this n required anywhere? Yeah, let's say as size. I'll say this as size, and let's see. Okay, runtime event teacher overflow. Oh, is this n? Oh, your n is big in this case. Your n is big in this case. That is a 2^31 minus 1. So that would not work. You cannot go on all the n's. You cannot go on all the targets itself. But still it is saying that you want to return the minimum of. So what you can do is, you don't have to go on all the targets. You can just simply jump off the values, which means I can just start off with the value as we saw previously also, right? Is just prefix what we need, right? We just can use 2 pointers, and rather than iterating on the entire, as you saw that I was at number 7, I was at 8, then I would directly jump on to my 16. But then in meanwhile I added a 10, because for sure as my 16 is more than 10, so I can just add on all the elements of my nums itself. I can add on all the elements of my nums itself, and as I'm adding on all the elements of my nums itself, I know that I can jump on to the next value, which is 25. So with this you should be able to do. Let's try this fact that that's the mistake in follow but put size. That's true. So what we will do is we have this t itself. Now firstly let's have this ll itself. Now this should give us a tle, but what we will do instead is we will have a prefix sum. Now id is less than my size, nums of id is less than my target. If it is less than my target, which is the current nums of id, if it is less than my the target which I want, I can simply add that in my prefix sum. Else what I will do is, it says the minimum number of patches required. No worries. Okay, so else I will do is if my prefix sum is more than equals to, if it is more than equals to my t, I can simply continue. Now rather than continue here, what we can do is we can say that my t will now become, because your prefix sum you know that it is more. So now at this point, let's take the same example back. You know that you have the elements 1 2, so now at this point your prefix sum was 7. Now just folks, let me know that if we want to solve this problem or not. But yeah, if the prefix sum is 7, so we just know that we have achieved a number 8. Like we don't have the number 8 with us. So with this prefix sum as 7, I will reach on to a 7, and next I'll try on for the next number, which is 8. So what we can do is we can just say my t is actually pref sum right now, because I can achieve every number up till pref sum. Now my t will become this pref sum, because I can achieve that, and then I'll try on for the next number, which is a t plus. So let's see. And by this you can see that it's actually got submitted. It's just that you just have to skip, as I showed you just have to skip to that value itself, because I knew that I could reach a number 7. I can just skip and directly say that okay, I'll try for the next number 8. When I am at the next number 8, I'll just skip and I'll just try for the next number 16. But as you saw, like before even checking, I will add any values if my prefix sum if it is more than this value, which is 10, so I'll just simply add this value in my pref sum. So I'll just simply skip to 26, like a number 25, then I'll check for number 26. So I'm just skipping if I can add it. If not, then I can simply add that in my answer, and that's how you can just simply solve this question also. Runtime is a bit okay. I guess it is sorted. Given a sorted, yeah, it is sorted, so we don't have to require to sort it. Now let's submit this again and see. As you will see, earlier it was a bit more, now it has reduced because we don't need to sort this also. So yeah, thanks to Shashank for letting us know this question also. So you saw that with the medium question of today's contest, you solved a hard question which has been asked by Flipkart recently in last 6 months, and also by Amazon and Snowflake. Cool. Again, thank you so much, Shashank, for letting us know. But yeah, should we solve it before to get the idea during the contest? Like you saw that I also did not know, but we can actually figure that out, right? Cool. If the folks are watching, can you please smash the like baby? That would be super great. But yeah, ID press on ID, that's true. Can we give a try along with your code once? Well, like with before code I gave and after code I gave. So I guess it was okay. Third question, hash map se hota hai kya solve? Oh, third question was actually another tricky question. We will see that also. So yeah, let's go on to question number 3. I'll say question 3 was not correctly made. Yeah, we'll just have a quick chat read. Should we solve such questions before to get the correct idea of in the contest? No, or was it solvable in the contest for someone who saw it for the first time? I was the one who saw it for the first time, so yeah, that was completely solvable. Yes, but still, idea still works in the terms of if such a number is not present, you always add a power of 2 as the next number, because it is because if the array is 1 2 4 8 16, you can find the number to 31. That's true. Port size is okay, that's true. But yeah, LC on high weeds, giving LC hard as medium, and that too as a second problem of contest, and not to mention constraints are from a stricter in today's problem. Yeah, that is true. That today's problem constraints are very strict. For example, for question number 3, there are people who solved the same problem, exact same problem in the same time complexity. Still, for a few of them it was just edge case passing, and a few of them it was minor, like just about to fail. So we will see that how this question can be done. Question number 3, and can you explain the changes, please? Oh, that changes. Char, what was the problem itself? Leetcode. Char. What was the problem name? I forgot. It was patching, patching array Leetcode. So the changes were just I commented the sort, and I just said that if here it was earlier continue only, and then I just added that okay, if it is less, then simply assign your prefix sum to a t, and then next time my t will increase and try for the next newer value of t. So you will just directly jump on to whatsoever possible values you are having. That is the only change which you have. Patched array. Yeah, that's true, Jay partner. Thank you. Cool. Let's quickly jump to question number 3. Let's see. Yeah, count complete substrings. Now, if the folks are watching in, can we please smash that like baby? That would be super great. Cool. We will have and see if everything is looking fine. Audio, video, yeah, that's true. Cool. Now it just says count complete substrings. Now again, there can be a high chance after watching this video, if you implement the same code, you might get a TLE. Many people in the discussion portion also, because when I implemented this, I got a TLE, and when I saw the solution, it's again people wrote the same code. It's just a small modification or the small change which got them the correct values, or basically the runtime being passed. Ultimately, you will see that we will achieve a complexity which should ideally pass in, considering the constraints which should pass in, but it will not pass depending upon what data structure you are using. That is a big red flag for any problem. Let's say if I'm using a vector and you are using an array, If it is passing for you and if it is not passing for me, it's a very wrong practice as a problem setter. So I think that this problem was not well made, and that's the reason you can also see that number of user tries are more and accepteds are less, because it's just a hit and try. Maybe it will pass, maybe it will not pass for you, depending upon if you just do minor optimizations. And I have seen, I'll show you, I have seen people whose runtime was 500 milliseconds, whose runtime was 900 milliseconds, same complexity code, just minor optimization. So that shows that the test cases were not well made. So no worries if even after watching the video you might not, like, you might still get a TLE, but that's a completely correct solution, and that lies in the complexity itself. And all these solutions which you see on the page itself are also of the same time complexity. It's just that a bit optimization, and that's not a very flagship optimization, a bit optimization can actually make you reach to a runtime possible solution. Let's see what the problem says. You are given a string word and an integer k. Now we are having a string word and an integer k. A substring of s of word is complete if each character of s occurs exactly k times. That's the first condition, that a substring. Now let's say that we have a string, the entire string. I can just break it into multiple substrings. Let's say this is a substring. Now these are some which I skipped it. This is a substring and this I skipped. This is some substring. I just made for this entire string. Let's say I made these all as the substrings. Let's say you can also say ending is something is remaining, something like that. Now with this, we have made the entire substring. We have made this substring like this. It just says each character in S. Now S is a substring. Each character in S occurs exactly k times. Here it occurs each character. Now character can be just 26. So whatsoever character is there out of 26 characters, each, like whatsoever is there, it occurs k times. That is a bit tricky statement, so just make sure it occurs k times. But that is one thing which we have. Okay, that's one thing. Now the difference between two adjacent characters is at most k. Just says one thing more, that the difference between two adjacent characters is at most 2. At most 2, which means that, now when I say difference, I mean in the terms of A, B, C, D, E, F, G, H. So C minus A, because if you just say 0, 1, 2, 3, 4, it's like indexing simple. So C minus A has a difference of 2. C minus B has a difference of 1. C minus C has a difference of 0. D minus A has a difference of 3. So I can afford, like let's say for example, if my character is C, I can afford to have adjacent character in my substring as either a C itself or a B or a A. I cannot afford to have, I can also afford to have a D, a E, a C. I cannot afford to have a F. So you will see that the difference is something which we need to make sure we are maintaining. Cool. Now return the number of complete substrings of word. Return the number of complete substrings of word. How many such substrings are there inside the word which are complete? Now complete is defined by these two conditions. A substring of an array is non-empty, all that stuff. Now we look on to the first example itself, and with that itself we'll actually try to figure out what we need to do. We have IG. Now my k is 2. What does this k mean? Firstly, what are all those? You'll see the answer is 3. What are all those 3? What are all those? Okay, what happened to this? What are all those 3 substrings? Let's firstly plot this up. We'll simply make the 3 substrings which we have. So you will see the first one is gonna be this one, IG. You will see I have just 2 characters, ing, and both are occurring 2 times, and both ing are having a difference of, like they are close now, A, B, C, D, E, F, G, H, I, J, K. So you'll see I and G are in the range of 2 itself, so it's good. So that is one substring which is okay. Other substring is this one. You will see again, it has 3 characters. It has 3 characters, and all are in the range of, like, all having a count of 2, which is what we wanted. It should occur exactly k times count of 2. That's true. And also you will see adjacent element G and E. Okay, G and E, again difference of 2. I and G, difference of 2. E and E, difference of 0. So yeah, for sure that's also true. Now last but not least is this E and E. That also has the count of 2, you will see. And also E and E adjacent have a difference of 0. So that is what he's saying, that you have these 3 as an answer. Now when this 3 is as an answer, what you want to do is you just have to figure out that how many such are there. Now I'll just say that firstly, this problem was not at all medium. It is marked, as you can go and see, it is marked as medium, but this was not medium problem. And even if we consider that the constraint of time complexity, which after submitting was a bit on the restrictive end, still it was actually a bit on the harder side. So no worries if you were not able to solve it while doing the contest. Coming on back, so we just see one thing, what we ultimately wanted. And now whenever we solve any of the problems involving substrings, we always land on to some specific character. This. Now I'm standing at this character. I just want to know how many such substrings are there which will end at this character. That's how we do it. Now let's say if I just ask you, you have a sub array, you want to find, like, let's say you have an array, you want to find all these sub arrays following some XYZ condition. So what do? You just go on to an index and you just say, okay, ending at this, ending at this, ending at this, ending at this. This is all these sub arrays. Now you'll go on to this, you'll just say this, maybe this, maybe this, maybe this, maybe this. So at every index when you land on to, you just say, okay, I end at this index. Now going back from this index, what all are the sub arrays which follows some specific condition. The same I can just plan for this. I'll just say, okay bro, I am standing here itself, give me all these sub arrays ending at this location. Give me all these sub arrays ending at this location. Now what is my first condition? My first condition is that every character, if it's there, it should be occurring k times. Now can I use this? Again, my task is I will have to go on to all the n locations, because for sure my size is of length n. So I will go on to every location n. Let's say I'll go on to this index. I'll ask him, bro, just let me know what is the size, or basically what is the number of substrings I can achieve if I end at you. Now bro, one thing, what is the starting range for you? We will go on to the starting range, but you will get to know that the starting range will actually be made sure by one thing, that let's say I have something, let's say I have x, now one thing. Okay, firstly we will just, as I'm standing here, my main task is to go on and try for every possible substring which should be able to achieve in my answer. Now when I ask you, what if I am saying your size should be k, you should have exactly k elements. So what all can be the groups which you can try off? You can try, let's say your k was 2, right? So you can try a 2 length, you can try a 4 length, you can try a 6 length. Bro, how are you doing it? Bro, I am saying if your size is 2, so for sure, which means your k is 2, for sure every element needs to occur 2 times, right? So if here is a e, so I am saying my e will occur 2 times. So I have one character e that should occur 2 times. So I'll just check that is it occurring 2 times. Now if I'm saying, oh, and I'll only check for the length of 2 itself, I don't want to check for length of 1 or a 3. I check for length of 2 because I know if the length is 2, I'll just say now, okay, if Aryan, what if it is a f? Yeah, if it's a f, that's not a complete substring. That's okay. But if it's a e, that's a complete substring. So I'll just check for a length of this length, e. I'll check for length of 2. Now I said that next time I'll check for length of 4. Now why is that the case? Let's say if it would have been a f, if it would have been a f, and let's say if it would have been a e and f. So you saw I got 2 characters, so now my expected length is 4, which is 2 into 2. So I know that in my English dictionary I have 26, which means A, B, C, D, E, F up till Z. I have 26 as my alphabets, right? And I am saying every alphabet should occur at the frequency of k. So when I am at this index, when I am at this ith index, is the index. When I add the ith index, I am saying I have one element. I know for sure one element will be there. So I will check for a length of 1 into k, right? Now next length which I can explore is 2 into k. Now this 2 represents I will have 2 distinct characters. Next length I'll check for 3 into k. Next length I'll check for 4 into k. Next length I will be checking for 26 into k. So I will be checking for all these lengths. Now your task, your main thing will become, okay, Aryan, that seems okay because you have a length n. Now for a length n, for this specific id itself, which is O of n into, you will go on to all the 26 possible lengths. It is a length. It is a length which you want to try. So k was 2, so you will try for length 2, length 4, length 6, length 8, and so on and so forth. You will keep on trying all these lengths. So that's a 26, which is okay. That's okay. Now when I say you will try a length of 2, okay, that was okay for this case, for the previous example, which is e into e. Let's say you had, let's say it, now this f into e. What you wanted. Now when I say, okay, you will try for length 2, but try as in do what? Do what as in check. Firstly, check out one thing. If its frequency, every character's frequency should match to this k, because I just checked, I just spoke, okay, I'll just try for the length of 2, which is length of 2 I'll try. But with this fact, I should have only one character having that frequency as k. So I will have to say that every character should have frequency of k. That was the prime condition for us. So when I will try for the length of 2, I'll just make sure I have a length, like frequency of every letter as k. If that is not the case, sorry, move on to the next character, like move on to the next length. So I'll try for the next length, which is 4. Okay, I'll try for the next length, which is 4. Earlier, like remember, this EF was not good. Now EF. Now I'll try for this length. For this length itself, I'll see, yeah, bro, the frequency of every character is k, which is good. Okay, so this particular substring is good, ending at this particular ID. Now you will see that next time you will try for some 6 characters. As for this previous example, you had a EE, which was great, right? Then you had a IG, so you'll try for length 4, which is not great. Okay, that's not good. So you will have a length of this 6 next time. That's a great. So you will see that when you tried for E, it will give you an answer of 1. You will try for IG, it will give you an answer of 1. When you will try for IG, E, it will give you nothing. Like it's not good. So you will see that ending at E, you will get 2 substrings, which is EE and IG, EE. Ending at G, you will get one substring, which is IG, right? That is how you will get the answer. But again, you just used one condition. Now, firstly, एक मिनट भैया, but आपने तो बोला कि n into 26 से तो आपने length पता लगाई, right? With 26, you got the length itself, which is this length. Now to check if this length is having that k, if this length is having that k as a frequency of every character, will you go on to this entire length of n? No, because with this you will become a n square 26. So you cannot go to entire length of n. So what you can do is, you know that you only have 26 characters in English alphabet. So you can maintain a prefix. You can maintain a prefix sum of frequency of characters. Now with this prefix sum of frequency of characters, what will happen is, I'll say I has a frequency of 1, G has a frequency of 1, I has a frequency of 1, I has a frequency of 2, G has a frequency of 1, I has a frequency of 2, G has a frequency of 2, I has a frequency of 2, G has a frequency of 2, E has a frequency of 1, I has a frequency of 2, G has a frequency of 2, E has a frequency of 2. Right now, when I want to say, bro, just let me know all the frequencies of element in this range, from in this range, entire range. So I'll just say, okay, I'll just point here, which is my R. I'll go on to L minus 1. I want to know, okay, what is the initial frequency? Initial frequency is 0 of L minus 1. Great. So I will get, okay, for all these locations, for all these characters I, G, E, the frequency is 222, which is equal to my K. So I will only have to check for 26 characters if I maintain this prefix sum of frequency of all the characters. So that is one thing which you will have to do a pre-computation for all the characters, such that you will be able to find the frequency in this length, because this length can be this, all these lengths. Now this length can touch n also, right? So to check the frequency of all the characters in this range, you just need a 26 because of this prefix sum of frequency of characters. Now everything seems fine, but we up till so far have only been using one condition, which is the K. Where did that thing gone? Difference between two edges element is at most 2. That is true. Now that is true. Why that is true is, what if I would have said, like, now you will say that, okay, next time you will try for a length of 8, right? But I'll say, bro, hold on, I will give you a left limit. Now this left limit will make sure that, bro, like right now you are saying, bro, you will try for a length of 8. Like earlier you try for length of 2, then 4, then 6, then 8. Will you keep on going until the very back? You should know that at what point, up till what point you can go. How will you know that? You will just maintain at any point. Let's say it was A and then I got a I. So for sure, A to I got a switch. That is for sure. These two can never be inside a substring, which is complete. So I will have to break here. So I'll just say my L starts from here itself. So with this fact, you will only be checking, as you were trying for all these lengths, right? So you will only check up till your length is actually like this length itself, or basically from this length you can just figure out the expected left index, which is nothing but if you have the specific r minus this particular length, and if let's say we give indexes 0, 1, 2, 3, or let's say it is 0, 1, 2, 3, 4, 5 and 6. So you know your 6, 5, 4, 3, 2, 1. So you know your r is at index 6. You know the length is 1, 2, 3, 4, 5, 6. So you will know that your L is actually here. So your expected L is R minus L plus 1 is your expected L, which is at this location L. So if I say, bro, your length is actually exceeding, which means if this expected left index, this will be expected left index if I consider this length of len. Now if this goes beyond, so, and my left index is this L, so I'll just say expected, I'll just write somewhere else, I'll just say expected left index. If it is less than my actual L, bro, simply break it, because I cannot expect, like, I cannot just go beyond this L. I have to stay inside this limit of L itself, because this L will make sure this L will make sure that I am in my bounds of my entire matrix, which is in this difference A to I. And with this, you can simply get this solved. That's the reason. I know that's a bit tricky. 1 out of 4 patched array Harkirat. No worries, no worries. See, his contest is a bit hard. We agree, and also the main reason for this to be being hard is because of some things. Like it was specifically for some specific like programming something. But yeah, it's expected for this to be hard. But just let's see. I see that many people have just gone because people just consider hard problems and people just don't stay for the hard problems. But no worries, whosoever is here, we'll just work together and we will have higher ranks. So you just saw ultimately what we did finally was, I'll just recap and then we'll quickly go on to the code. Ultimately, what finally we did was that just make sure, just comment down below whatsoever you guys have queries or doubts or suggestions or anything whatsoever you guys have. Cool. Now we just saw one thing, that we will have these two conditions, which is for k and for this at most 2. For this at most 2, I will just do one thing, that whenever I am moving at my index I, whenever I encounter any change, let's say I was moving index I, I was moving previously. If I encounter any change, I will mark my left and will just say if my s of I minus s of I minus 1, let's say if it is ith index, it is I minus 1 in the index. If I say if my s of I minus s of I minus 1, again take a ABS value because you want just that. If it is more than my 2, then for sure it is a time to update my left index to the specific I itself. Right now I'll update my left index to this I. This left index will make me sure that I can just only try for this specific range from, because my I will keep on moving. I will keep on moving. I'll let's say reach here, so I should be knowing that whatsoever length I am trying, because I'll try for the length of k into 1, then I'll try for the length k into 2, I'll try for length k into 3, I try for length k into 4. Now as soon as my this length k into 4, so this length is k into 4, so I'll just find out, okay, what is the expected left index for this length, which is actually current index I minus my this length, which is k into 4 plus 1. Now if this expected left index, which is this value, if it is less than my L, bro, you cannot go you cannot go before L. So please simply skip it or simply break it. You cannot try for any lesser values of L, any lesser, like any more values of lengths, because for sure if you will try for more value, which is k into 5, which will for sure go before k itself, so you cannot try that. So with this you will know, okay, you will have a I, you will have a L. Now you know, like, okay, what conditions you have to try for this specific length, and at every point of my I will try for all these values, which is k into 1, k into 2, and so on and so forth, which is up till maximum till 26, because you know that you will have testing 26 characters. That's it. And to find the frequency, because if you try for a length k into 2, if you try for a length k into 2, so you will have to somehow figure out the frequency of all the characters. So just to verify that, okay, if this k into 2 length is correct or not, you will have to figure out the frequency of all characters in this length k into 2. So what you will do is you will maintain a prefix sum of frequency, and with this you can easily get this solved, because prefix sum will help us maintain and tell us what is the frequency, and this prefix sum of frequencies will be of length 26, because you know now, because see, prefix sum you can have it of this entire length n, but it will have 26 characters only, and with this you can maintain these 26 characters. So ultimately you will see that your time complexity is O of n, because you go on to every index I, at every index I, you will try on for all the possible lengths. There are 26 possible lengths, which is k into 1, k into 2, up till k into 2, k into 26. To try for all the possible lengths, you have to go and verify for the frequency of all the characters inside that length. Earlier it was taking O of n time because we are going on to the entire sub array, but now we will use the prefix of frequencies to get it in O of 26, because we know we only have 26 characters in total, and that's how you can simply get this solved in O of 26 square into n. Cool. Let's quickly see how we can code this up, and just quickly write down that if you guys have any of the issues, or can we use sliding window, that is a sliding window itself. What we are doing is a sliding window itself. See, if you want to achieve the same stuff by sliding window, the only thing, see, again, the complexity itself will still remain same. The sliding window will just make sure one thing, that as you saw that you had IG, E. So earlier as I was saying, you were trying this length and then this length, right, when you were at this specific index I. Now sliding window will just make sure one thing, and again when you will be at this index, when you will be at this index, you will try this length and this length, right? It is what I told. Now sliding window will just do one thing, that when you are at this index, you will try the length of 2, length of 2, length of 2, right? When you are at this index, you will try a length of 4, length of 4. So this is a length of 4, this is a length of 4. So you will see that this length of 4 will give you a value, this length of 4 will not give you a value, but this length of 4 will give you a value, and then ultimately you will try for length of 6. So that is how, like, length of 2, length of 2, length of 2, length of 2. That is how, what you mean by sliding window itself. But still, to just have a sliding window, you will be going on to all the elements, which is n elements, to just have a check on if you can encounter that. So you will try for all the window sizes, which is actually 26 into k. Like the length is 26, the window length is 26 into k, but the options are 26. Now when you try for the window length itself, you will have to make sure that if it's actually having the correct frequency of elements, which is actually equal to k. For that, again, you have to go and try for all the 26 alphabets and check for their frequencies. Again, for this, you will have to maintain prefix sum itself. Both this approach itself, which is a sliding window approach, or the previous approach, which is a sub-array approach, both will take the same time. It's just that anyway, whichever feels comfortable for you. Again, I'll repeat this sliding window approach, as JE partner spoke, is just that we will try for all the window sizes, this and then this and then this and then this. Now let's say it was a window size of 2. For 4, we will try for this length, this length, this length, and so on and so forth. Earlier what we were doing was, when I was at this location E, I was itself trying for length of 2, length of 4. Now he is saying length of 2 here, length of 2 here, and so on and so forth. So it is just that howsoever you want to solve it, you can get that solved. Cool. Just comment down below whatsoever you guys have queries, and we will now code it. And for sure, that's a hard question, so you can just take a pen and paper and just dry run. You can just dry run along with me also, or you can just take after the live stream also, you can just have it done. That would be great. And again, yeah, if you guys are liking it, can we please smash that like baby? That would be super great, because usually people don't bring out these contest discussions. We are the kind of only ones who brings it live for you guys. We tried to have the videos, but yeah, that was, you guys loved it. So yeah, just as you say. So we'll just quickly have the code for this. So yeah, as you saw, we need to have one thing, we need to have words itself, and just comment down below whatsoever you guys have. We firstly need to have the frequency itself. J partner, thumbs up. Cool. We firstly need, as we said, that we need to compute the frequency itself. So what we will do is we'll go on and say that we can have maintain a frequency array. Now this frequency array will be similar to saying frequency array of length n, but like length n or n plus 1, depending upon if you want to have it done using unordered map or simply using vectors. As I told you, it might give you TLE. So if you use unordered map or stuff, so we'll use simple vectors with the fixed sizes. Now with this, you will see that the frequency will maintain and say that we want the entire length of array size of n plus 1. We will say that our frequency of all 26 characters we want as n. Now we will start off with every character, every word, every character in this string, and for that specific character I can just keep on maintaining the frequency. Now I want the prefix frequency, right? So let's name it as a pref frequency. Now this pref frequency for sure, as you see, it's a 0 based. We will have to make it 1 based, so that's the reason I just took it n plus 1, because we will have to make it one based. So we will make it 1 based. Now firstly, as it's a pref frequency, so we need to have the previous frequency also. So we'll just simply copy the previous frequency in the current frequency, which is I plus 1. Again, pref frequencies is 1 based, and your this normal frequency, your pref frequency is 1 based. So for index I, your pref frequency is having a value at I plus 1, and for sure you just copied the value, but you did not use the current which is the current character itself. So I'll just use the current character, which is word of I, but that is in the integer, like that is in the ASCII form A. So I have to subtract A to get it in the integer form, and then we'll say that just simply increase its frequency. Now that portion is done, which means I have computed my prefix. Vector spelling, vector. Thank you so much, Jay. Partner, I guess only Jay is studying, or like no one else is studying. Cool. So now as we saw that we need to have a left index with us, and we will also have an answer. So it can be integer, right? So that is an integer. So the answer can be integer. So I'll just initialize my answer. Or let's do it here itself. I will have my answer. Now comes the interesting part, that we will have to go on to all the indexes which we have. As we saw now, that we'll go on to all the indexes. So I'll go on from 0, which is less than n, and I plus plus. So you saw that I go on to all the indexes. Now comes that part, as I showed you. Vendor. Is it change? Oh, vector. Oh, vector. Okay, now it's correct. So as I showed you also, that I will have to check in for this L thing, right? Now where's my marker? Now L thing, which is I'll just check for this ith index and I minus 1th index. If this and for sure I can only check my I minus 1 when my I is greater than or equal to 1. So that is one condition right now, right? So I'll just go and have this a check, that if my I, which means s of I minus s of I minus 1, if it is more than my 2, then I have to update my L and bring in my L to this specific value, which is I. So I'll do the same stuff. Now here s is word. So firstly, because I know that I need to have a L as my value, so I'll just make sure. Now code vector, thank you so much. I guess it's correct. Now I will just make sure that I will land onto this value, which is vector word of I, but specifically I was about to go and do a minus of word of I minus 1, right? Now that is more than that is more than 2, but as you saw that it can be absolute value. So I'll take oh, where is that gone? Yeah, Yeah, so that should be more than my 2, but that needs to be absolute value. So I'll just take the absolute of this, and that should be more than 2. But then for I equal to 0, it might give a null pointer, so just add a 1. So now this becomes a condition that if I is more than equal to 1 and your absolute value of 1 minus 2, if it's that is the case, then simply place your L pointer, which is the left, as this I itself. Now, as I showed you that I am now standing at, I'll just comment. Now I am standing at ith index and will try for all lengths. Now this length is from 1 into k to 26 into k. So I am now starting on the ith index, and I'll try for all the lengths itself. So I'll just say that I'll try for all the lengths. Now let's name this variable, this 1 to 26, as some variable. So I just say that I have to try for all these lengths. So let's name the variable as E, F, G, H, I, J, X, Z. Let's name it as a variable as C. So we will start off from C, and we'll just try for all the lengths, which is 26, and then C++. Now, what length I'm going to try? I'm going to try for length C into K. Now, this is the length which I'm going to try. Now, as I showed you, if this is the length, I also want, okay, what is the expected left index? For this length, what is the expected left index? Which is nothing but I minus L plus 1, I minus L plus 1, as I showed you in the code also. Now, this expected left index, expected left index is less than my, if it is less than my actual value of this L, which means my expected left index is low, expected left index is this. If I am at I know the length which I'm going to try is this specific length. Now this specific length, so I just got expected left index as this. Now L is afterwards, this expected left index is here, so I know for one thing for sure, I cannot try for this value. So I just have to say, bro, you cannot try for any bigger lengths also. So I'll just say if this is the case, which means you cannot try for any bigger lengths also, and as the length will grow bigger, this expected left index will go much more lefter, if that's a word. So if that is the case, what I will do is I'll just simply have a break, because I cannot try for any bigger lengths. So one thing for sure, I cannot just go and try for any bigger lengths. Now, if that is not the case, now your task is to find the frequency. Now your length, length is len. Now check if frequency of every character in this length is k. That is my question. That is what I have to check. So I will have to figure out the frequency of every character in this specific length, which is length. With this fact, I have made a frequency which I will use, but you will see that I cannot go to the entire length. So I will try for all characters. So I will try for all 26 characters. That I just try to see for all 26 characters, either the frequency should be 0 or the frequency should be actually your k. So I'll just try for all the 26 characters. Initially the frequency is 0. Now I will just say one thing. I'll go on to all of my characters for auto C. Okay, C I have already taken. So I will just say that for auto character ch starting from A, your ch is less than equal to z, and then ch plus plus, which means you are trying for all the 26 characters. Now you know that the sky value you need to have for those specific characters. So firstly, you will try to find the frequency of that character. Now I'll just say frequency of that character ch. Now this ch is number based, so do a minus a for sure, or you can also just minus a, or you can minus a, or you can also just go on to from 0 to 26 less than 26, that also will work. But yeah, just to have a more systematic feel, we're actually using this. Now what we will do is, we know that okay, for the current frequency, which means for the specific character, the frequency, just let me know the frequency of the specific character. So I just can go to my prefix of frequency. I'll just say, bro, prefix of frequency, I am standing at what index? ith index. I'm standing at the ith index. So I'll just say, because that was 1 based, so my value is being stored at I plus 1. I want at I plus 1, like at the ith index, I want the frequency of this character ch minus a. So this is a frequency at ith index, but I know that my left is at this bound, so which is this specific portion, right? This your expected left index is at this. So you want to know that from the expected, you want to know that, let's say your length would have been this portion. So this is your expected left index. This would have been your expected left index. So you want to know the frequency of characters in this range, right? So I'll do the same thing. I'll go and say that prefix, again, as you simply do and find out for your specific frequencies, right? So I'll just do a prefix of frequencies of expected left index. Now, although expected left index, I would do a plus 1 because it is 1 based, right? So I'll do a plus 1. But then you know that when we do a prefix of this range L, let's say here is L, here is R. When we want to find a prefix of this range L to R, we do a prefix of R minus prefix of L minus 1, right? So we will do a minus 1 also. So you saw plus or minus 1 will cancel and we'll get simply this value, ch minus a. Now you have got the frequency of that specific character, which is this frec. Now your main task is to just let know that this frequency, either it should be a 0, again, either it should be a 0, or if it is not, it should be a k. So I just make sure one thing, that firstly I will have to make sure that my frequency of every character is k. So I'll just have a check here that my frequency, I can also have a variable also, right? Int frec, which is 0. That I don't want. I can just have a frec. Oh, I can just have a frec variable here itself. Int frec, which is the frequency of that specific character, which is ch right now. And I can also have a boolean, just saying that if I have encountered all the elements with that frequency, so I can have a flag. Now this boolean flag, let's initialize that with a true, right? So I'll just have a check if this frequency is not equal to 0, and also if this frequency is not equal to 0, which means that character is there, and this frequency is not equal to k. If that is a case, bro, just make your flag as false, or you can just say flag is false and simply break from here itself, or I can just write this in the same line, flag as false and break. So I did one thing, I just made the flag as false and I just simply did a break. With this, if my flag is still there, which means if my flag is still true, so for sure I have got a good value. So simply I would use that good value, and let's remove this. I don't think that's required. And with this you will keep on incrementing your answer, and ultimately you can just simply return your answer. No code. Thank you so much. Okay, we have a compile time error. Can't we write like this? Flag as false. but I think, yeah, I need to put this in brackets. Let's put this in brackets and let's see. So we are 3636. Let's see, let's submit the code and it should get accepted. Now again, this got accepted, but there can be a chance that if you use something extra, it might not get accepted, which means if earlier, like what I did was I used my vector, I just used one vector here extra. So you saw that a flag was just more than sufficient, but I used a vector here, so that increased the time complexity. So if you just go onto these details, it will be around 900. See, it is around 12967 milliseconds right now. Again, that is a small optimization which we can have. Let's say if instead of this vector, I know that it's a fixed size, I can have it as a array of int. Again, you saw that previous thing was passed, that's good, but again I'm just showing you that how this small time complexities can actually impact your run times. Why you think that why so many people just tried this but very less people got it? Because of this small issues. So I just have array of the fixed size which is int. I'll just remove this entire part. Right now you see that I just did a small, very small change, right? That's the only change which I did. Let's quickly check if everything is working fine. Right, and you saw I just did a one line change. You will see the time complexity getting reduced by more than, see, it's half. Can you just imagine that? It's half. That is the issue with these test cases. So in general, the time complexities are not that much restrictive. So now what I mean to say by that is, if anything you would have used extra in this particular code, you would have got a TLE. But I showed you that here earlier we were using a vector, we just reduced to a simple boolean. Here we were using a fixed array vector. Again, we got that pass, but it was around 1287 milliseconds. Here we saw we just reduced that to around 600 milliseconds, and that's how you can simply get things solved. Cool. We'll quickly go on to next question, which is question number 4. I see that the energy is a bit down today. I see many folks are not there. We have Vamsi is here. We have no code. We have Udita. We have J partner Harkirat. We have Tag Ansh, Karandeep. We have Krishna. We have Shashank, Tag, Om Kumar. So we see that we have a few regular ones, and there are quite a regular ones also we are missing. Vamsi is back. Great. For the regular ones, just keep on commenting so that I just get to know that sorry for late, I have in a trip Kerala. That's great, Vamsi. Yeah, but just in general, keep on commenting so that I just get to know that regular vibes should come in, so that it feels like you are solving problems, you are solving contest, right? Cool. We'll go on to question number 4 quickly. Now for question number 4, again we can have multiple optimizations, but yeah, question number 4 was a bit tricky to understand, also to implement, also, and to think also. I don't think even if you would have known it, like, okay, oh shit, my laptop has gone. Can you see this part? No, you cannot. Okay, so but yeah, I can just still go on to this portion is still working. But yeah, meanwhile the folks are watching in, and if they have liked the question number 3 explanation, they can smash the like, baby. We'll quickly go on to question number 4. It says count the number of infection sequences. Now it just says that you are given an integer array n and of indexed. Again, this is gonna be the most intuitive explanation you could get for this problem on the entire YouTube ever. I'm saying for the next 1 year also, because for the question number 3, there can be a chance that maybe if it comes in your daily problem discussions, I will bring a proper like written down notes and stuff. But for this, I have already written down notes for you guys. Just like for the problems, like, it's the reason that it got a bit late, just because I was making the notes for this problem for you guys. That's the reason. I just wanted this problem to be as good as possible. Now, going on, let's quickly see that if we have anything. No, we have. Cool. Again, we'll go on to question. We are having an integer n and a zero index integer array called as sick. Now, sick is sorted in the increasing order. That's one thing. Make sure that your sick is in the sorted order. Now, there are n children standing in a queue with a position from 0 to n minus 1. Again, there are n children from 0 to n minus 1. Now, I'll just quickly go back and say that what the problem says. You have n children, you have 5 children, 0, 1, 2, 3, 4, and 5. You have 6 children at these indexes, which is 0 and 4. Right? You have to figure out the number of ways how the children can get sick next time. How a children gets sick next time is at each second, a nearest child to a sick child gets sick. So what will happen is sorry, it is a array of size 5. So the next will happen is nearest child to a sick child gets sick. So I can initially make this child sick, which is P1. Then what will happen is, if this child gets sick at the first duration, again, it's not the only child, he can also get sick. Now P1 is just a try, just saying, okay, this child is getting sick. P1, at the first try, he's getting sick. Now again, I can just show you this, that it can be represented as, I'll just copy the same stuff down, paste, it is pasted somewhere else, and I just copy and paste the same stuff down. Let me paste this, it is pasted here. So you saw that in the initial beginning, I can make P1 as sick, I can make him as sick, which is the third child, and it's the first child which is getting sick. I can make him as the first child getting sick, which is the first child getting sick, as the first child getting sick. Now next duration, you will see that I'll still copy this up. That's example, although we'll look at a very good example, but that is for you just to show, or you just to make sure that you understand what is kind of required or being done. It's just an example explanation. That's not a deep explanation. You will not get much stuff from this. So you saw that next time, when let's say first time you got to him, now again he can get sick or he can get sick, so I'll make him as sick, or I can make him as sick. So for sure, for the last one, he's the only one remaining, so he will get sick. Last May he'll get sick last. He can get sick. Let's say make him as sick for the number 2 person, and number 3 he can get sick, which is fixed. So you will see ultimately you have these 4 combinations: P2, P3, P1, P3, P2, P1, P1, P2, P3, and P1, P3, P2. All these 4 are the distinct patterns which I can make my person sick, and that is the answer itself, 4. So that is one thing which you got to know from this question. Now coming on to the part that okay, that is one thing that we can also figure out by just saying, bro, why you did so much of the Jhanjula as in headache. You can just say that if he is sick and he is sick, for sure, for the next person to get sick, I have 2 options, this and this. Okay, next person to get sick, I have 2 options. Let's say again, I am saying I have 2 options, which is 1 and 3 locations. But for sure, only one can get sick at a moment. So let's say he gets sick. When he gets sick, again I will be left with 2 options. Okay, again I will be left with 2 options. Okay, and you again place someone in last, will get only 1 option. Okay, that's 1 option. So you saw that is 2 raised power 2. How to generalize that? Simply, I can just say that if I have sick empty, 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 sick. So it is 0, 1, 2, 3, 4, 5, 6, right? I have 7 students, right? Now I am just simply saying I have my 0th and the 6th student as sick. So for sure, again the same pattern. For the first student to get sick, he has 2 options, this or this. Okay, 2 options. Let's say he got sick. Again, he has 2 options, this or this. Again, let's say he got sick. So again, he has 2 options, this or this. Okay, 2 options. Again, let's say he got sick. Again, he has 2 options, this or this. Okay, cool. Again, 2 options. Again, let's say he got sick. So again, last me, he just has 1 option. Okay, 1 option. So it is nothing but 2 raised power 1, 2, 3, 4, 4. So you will see that the options available in the beginning were 1, 2, 3, 4, 5. 5. It is nothing but whatsoever. If you have a sick, if you have n as the number of students in between of 2 sick students, so you will have 2 raised to the power n minus 1 as the options. So that is the solution which you have a first inference or the first intuition out of this question, right? That is the first intuition out of this question itself. But if I ask you, bro, if you have a sick, you have n children's in between, right? Now again, you have m children's next and again a sick. So you know, for this, the options which you have got or the patterns which you have got is these patterns, like in this order itself, right? So for sure, this will have a 2 raised to the power m minus 1 as an option, and this will have a 2 raised to the power m minus 1 as an option. So are we saying that can we simply multiply that and get the answer? Are we saying this fact? Again, are we saying this fact? No. That you might say, okay, bro, but you will take everyone. No. So for sure, you should take this and multiply this. Yeah, I agree with you. You will multiply this, but you're missing something. That is the hardest part to visualize, that you have got the correct approach, but when you will go and apply the same approach on the other like on the explanations which you have, you will see that you are missing something. Let's see what I am trying to say or what you are missing. So I just took the same example. X, I have some 3 people in between, 3 students in between, and then X, which is the sick child, and then again 2 students in between, and then again a X. So you also, by the fact which you saw previously, you will have a 2 raised to the power 3 minus 1, which is actually a 4, and again a 2 raised to the power 2 minus 1, which is actually again a 2. So on multiplying, and what this 4 means, again, what this 4 means is you are placing your child's being sick in the order. You can, as I showed previously also, you will have these 4 as the orders: P1, P2, P3, P1, P1, P3, P2, P1, P2, P3, P3, P2, P1, P2, P3, P1. This indicates I placed this child as the first child getting sick, next is this child, next is this child. This is the order of these child. P1 indicates this specific child on this specific location. On this location, he was the first child to get sick. Like this P1 indicates that at this location, it can be a specific index, it can be a second index. At second index, whosoever was the student was the first student to get sick. This indicates that. Now the same I can do for this range also, a D1 D2 or a D2 D1, a D1 D2, which means he gets sick first and then he gets sick, or I can say he gets sick first and then he got sick. I have just these 2 options. That looks very fine. Now when I multiply these, so for sure this will be multiplied with this also and this also, so for sure I will get 8 as an option, which is what you were also guessing. You were also guessing that it should be the answer, but I'll just prove your theory wrong and will show you that it will have much more answers. And while proving the theory wrong itself, we will figure out that what was actually needed or required to solve this problem. So what we did was we just simply multiplied. We got a P1, P3, P2, a D1, D2, P1, P3, a P1, P3, P2, a D2, D1. So that is nothing but I simply got this first row multiplied with these 2 rows, and I'll do the same it for the second, third and the fourth, multiplied with the 2 rows. Okay, so you saw that you got the 8 answers. right? Now you are saying that only these 8 are the required answers. I'll say no. You will have 80 answers. You will have 80 possible such patterns. How you will just feel and realize for this. And one thing you will for sure agree that all these are the distinct patterns itself. All these 8 patterns are the distinct patterns. But here, did you see one thing? What is the mistake which you are doing? Did you see one thing? You are placing all the P's together and all the D's together. I said one thing, the order which is D1 will come first and then D2. That will for sure be maintained. But who said that my D will come after P or before P? I can have it anywhere itself, right? That is where, because now why I'm saying if I just place my D itself here, my D2 will here, and D1 is here. So for sure, you are replicating the same scenario down below. So you cannot reorder the elements, which means you cannot like make your D. You will maintain the D order, which means D1 is on the left and D2 is on the right. That order will be maintained, but it is not restrictive that your P1, P3, P2, which means P will be together or D will be together. That is not a restrictive case for you, which means you can just simply expand that also. How? You can just imagine this as 3 things: P1, P2, P1, P3, P2. Now, as I showed that it was never important to just place a D1, because you just want what are all the possible such patterns. Like you wanted an infection can be sequence. It can be shown that there are finite number of seconds and all the children in the queue will get infected with the disease. An infection sequence is a sequential. An infection sequence is a sequential order of positions in which all the non-infecting children get infected with a disease. So this infection sequence is a sequence which we want. Now, I never mentioned that firstly the first group should get disease and then the next group should get disease. I never mentioned that. It can happen that the first group and then the next group, the first group, and then maybe the third group, so on and so forth. It can still happen. So one thing is for sure, that this portion can still happen itself. So I just maintained one thing. It's a P1, P3, P2. I have a D1, D2. So I can just simply try to this technique is called as a stars and bars, where you place one thing, where you place your stars, and I will try to place bars. So imagine these P1, P2, P1, P3, P2 as stars, right, which are there itself. Now imagine these D1 and D2 as bars, So I'll just try to place these bars in these locations and try to figure out how many such patterns are possible. So maybe I can place both the bars in the end. I can place my D1, D2 in between. I can place my D1 and D2 here. I can place my D1 and D2 in the ends. I can place my D1, D2 both at this location. I can place my D1, D2 here itself. I can place my D1, D2 here itself. I can place my D1, D2 here also. I can place here also, and I can place in the starting also. So these are all the 10 possible options for the first. You thought of 8 ways, but for every way I found out the 10 possible combinations. Now that was via doing a dry run, which you saw. But how is the formula? As I showed you, it's a stars and bars. Now what happens is, you had 3 stars, which is P1, P2, P3, and you had 2 bars. Now your main task was you can just imagine this, rather if you just say that you have 3 stars and you have 2 bars. Now you have to just keep on placing these bars in these locations, which means you have stars, you will just place a bar here, or place a bar here, or place a bar here, or place a bar here. That is what we are doing also. Imagine these stars as P1, P2, P3 and the bars as D1, D2. That is also what we were doing earlier also. So with the stars and bars, how this formula is derived is, we just say that okay, we have 3 stars and 2 bars. So let's imagine we have 3 plus 2 as 5 locations. Now out of these 5 locations, I can choose any 2 location to place my bars, and the remaining places will be for sure for stars. So that is how you derive the relation for stars and bars. It is nothing but stars plus bars C of bars, or you can write the same thing as stars plus bars C of stars. C of stars. So that is how you derive the relation of stars and bars. That it is, you have a star count, you have a bar count, you have do a C of bar count. So if you go back above, we have a star count of 5, we have a bar count of 2, sorry, we have a star count of 3, bar count of 2, we get a 5C2. Now 5C2 is 5 into 4 by 2, which is actually a 10, and that's how you got 10 ways. So you now figured out that this is, with this you will get, okay, I'll just simply multiply these pattern, I'll get 8 ways, but I can also arrange those 8 ways by using stars and bars. Now with this pattern, I'll just multiply that by a count. Now what should be that count? That count should be a stars plus bars of stars itself. Now the stars plus bars is, you will see, are the empty places. Now here the empty places are actually 5. So I'll say empty places C of what? C of the bars which you have to place, or I can also say as this last, it is a bar, right? For me, I took this as a star, this is a bar. I will expand this theorem also, but yeah, this is a star, this was a star, this was a bar for me, right? So I just say that, okay, I'll just use this group size. So let's say it is a group size, let's say G. So I'll use empty spaces C of group size, and that would be my answer. But now still I have just expanded my problem a little bit. Still I have to expand it a more. Now when I say expand, I mean 2 things. One thing is, you have a X, you have some empty places, then you again got X, then you have some empty, then again X, and then some again empty, and then again X. And then you also saw that you can still have the empties in the starting also. One thing for sure, that if I just ask you X and some empty spaces in the starting, you will only have one pattern, which is P1, P2 and P3. You cannot have any other pattern for this ending portions, and the same goes for this ending part also. You will have only one pattern, which is P1, P2, P3. You will have only one pattern for this ending or for the starting. So what you were doing here was, you were just trying for all these patterns, right? You were trying for all these patterns and you figured out some formula for this pattern. But if I just say you, if I have these 3 also, let's say 3 or maybe any number of in the beginning, if I would have asked you, so would you have said that I will just again, for sure, for the starting portion, it will have only one pattern, as I showed you, P1, P2 and P3. So that's only one pattern, P1, P2 and P3. That is just a one pattern multiplied by 1. So this, if I have anything in the starting or anything in the ending, this multiplication which we are doing of the, let's say if I found this group size, which means between these distinct patterns, between this distinct people who were sick, for sure this starting portion of people will for sure not impact in this formula right here. It will still have an 8. But again, you saw that, let's say it name it as a E1, E2, E3. We will name it as a E1, E2, E3, E1, E2, E3, E1, E2, E3, sorry, E3, E2, E1. That is one thing. But you will see that still, if we even have this, but Aryan bhaiya, what if you did not count it in these ways? These ways will still remain 8, but we can still arrange these ways, right? As we saw that we can arrange these, we arranged these ways, still we can arrange these ways also. Yeah, you are absolutely correct. So how we will do it? Simple, as we derived this formula itself. Empty spaces, see my group size. How? Let's look back. We will just simply erase this part. Okay, we will not, because we need it again. We will just copy this part and we will copy it down below. Now we have copied this. So now what will happen in this when we have, sorry, empty, yeah. When we have these as the empty places, we know that inside the formula we have these three as the places, we have these two as the, sorry, these three as the places for sure. This will give me 1 in my that formula. This will give me 2 raised to power 3 minus 1 in my formula. That will be nothing but 1 into 2 raised to power 2, which is actually 1 into 4. So 4 is the number of multiplication groups. But we can also have a stars and bars for these groups. Simple. We know that this will be those four. This will be just 1. Again, if we use the stars and bars previously, we know that we have this group, we have this group. In total, number of empty places are 6. This 3, and also you got this group as the new group. You can use anyone as the bar. I'll use this as the bar. So C of number of current in the group, which, because I am going in this order itself, so I know this is the group size right now. Group size of 3. So I just simply multiply with this 6C3. So with this, okay, you will get the answer. But bhaiya, ye to why? Firstly, bhaiya, first question, why you did not take this as a group size? And next question is, what will happen if we encounter next group? How will you do it? Will you do it for every group? No. That is the reason I took this as the group. Why this as the group? Because as we will keep on going, next time we will encounter some other group. So for sure, right now you have got these as the number of ways. Again, these are this was the incremental way. Initially you got one way, no group pattern previously, nothing like that. Okay, one way. When you saw again, we'll just let's go incrementally. Initially we have these 3 as a group size, right? But we saw that our result was actually 1. That is a by default value, because we will simply keep on multiplying by 1. That is how we do a simple PnC. Now 1 is for this result, okay, but we can just do a stars and bars with this, with some previous group. But for that you just need the entire number of empty spaces. Empty spaces are 3. Current group size is 3. 3C3 is again 1. Okay, that is a 1. Okay, that first group is done. Next group I encounter again of size 3. Okay, which again your result has been 1 into 1 so far. Cool. Next you encounter a group of size 3. So with this you can also imagine one thing, that it's of no point to go on to the first group, because it will for sure keep on like make your first result as 1 itself. So it's of no point to go on to the first group itself. We'll go on to the next group. Next group, if we go on, for sure, firstly its impact is 2 raised to power 3 minus 1, right? Again, modulo is something we'll do at every step, but yeah, 2 raised to power 3 minus 1. I guess my battery is dead. Okay. But yeah, if the folks are watching in, can we please say something like if my audio and stuff is fine? I'll try to have this if possible, if this is good. Yeah. This is the only thing which I have. Cool. Yeah, we'll go on to our explanation back. So yeah, everything is okay. We'll go on to the question, Pratyush. No worries, we'll go on to the question, but yeah, I will just quickly finish this off. Cool. So if we encounter this second group, again, that is the way which we can make groups, but still stars and bars need to be done. Total number of empty places, again, stars and bars is considering these as the bars, previous as the stars. How will you place these as the bars in the previous locations? Empty spaces are 6. I will do current as 3. I will get my all possible combinations. How was that possible? Again, I imagine this as a star, this as a bar, and I will be placing these bars at locations. Now with this I will get all possible 6 into 5 into 4 upon 6 which is 20. I will get all 20 possible combinations. Just remember this fact. Just remember this fact. You will get all 20 possible combinations for every corresponding. Let's say here it was E3. Sorry, here it was E3, E3, E2, E1. Sorry, it was E1, E2, E3. Here it was. Let's say the current combination was P1, P2, P3. So for this P1, P2, P3 with this corresponding E3, E2, E1, you will get 20 possible combinations. And how many such possible P1, P2, P3? These can be 4 such possible kind of patterns. Again, remember, for one such pattern, you will get 20 possible combinations. Remember this fact, because that will be useful when you will be multiplying the next element. Now, as we go on to the next element, we will encounter a group of size 2, right? Group of size 2. Firstly, just the impact as in the pattern itself. He will give me a 2 raised to power 2 minus 1 as an impact. But now I will again have to apply stars and bars. Now is the interesting fact. On what number you will apply the stars and bars? Will you apply the stars and bars on this number itself? On this number itself? On what number you will apply the stars and bars? You will apply the stars and bars on this previous arrangement. You have got 20. You have got 20 as the previous arrangement of these 6 values. So now your stars is a 6, your bars is a 2. Now remember this fact, your stars is a 6, but this 6 has been arranged 20 times to get all possible 6 stars combination that has been already arranged. So make sure that all possible combinations of stars have been arranged. All these 20 combinations are there. So I'll just simply say my star count is 6, my bar count is 2. So I'll just do a simple of 6 plus 2 C2, which is actually nothing but a 8 C2. Cool. Now with this I will get my all count. Next encounter I encounter a 3 count, so I'll just do a 2 raised to power 3 minus 1 multiplied by simple existingly number of empty places is 3 plus 3, which is 6, plus 2, which is 8. 8 is a star count, 3 is a bar count. I'll get a 11 C3 as my possible number of stars and bar combinations, including this group. Now bhaiya, what if I have a last as empty itself? Again, the same as we did for the if I get an empty in the beginning, I'll simply have a 1 contribution for its patterns and the stars and bar combinations. Again, what is the count? The count, let's say here would have been a 4. Let's say here would have been a 4 count. So I would have said, okay, 3 plus 3 plus 3 12 plus 2 14. 14 is 14 is okay. I have just done one thing wrong here. It is 11 C3 ni 3 plus 3 plus 3 plus 3 plus 3 is 9 10 11 C3 11 C3, correct. So I will get a 3 plus 3 plus 3, which is 9, plus 2, which is 11, plus 4. We have a 3 plus 3 plus 9 11. We have 11 stars and 4 bars, so we'll get a 15 C4 as a stars and bar combination corresponding to this last value. And with this will be your entire answer. So with this, it will cover the mid values, the start value, and the end values itself. Now this portion we can do by doing a binary exponentiation, binary modulo exponentiation, which is nothing but finding out a raised to the power b mod m. This is this value. Now this is a NCR. For this we need n factorial upon r factorial into n minus r factorial, right? For this we need a n factorial, which is nothing but multiplication of n numbers, like n into n minus 1 into n minus 2, and also you would need the factorial, or I should say inverse of r factorial multiplied by inverse of n minus r factorial. factorial. So this is factorial. You can just calculate, just pre-compute everything. Pre-compute n factorial, pre-compute r factorial, pre-compute n minus r factorial, which means pre-compute all the factorial values. Now, bhaiya, if I want to do an inverse of a number, let's say a, which is nothing but inverse of a number a modulo m, you will see everything is a modulo m. Modulo m is a prime number, right? So if I want to do an inverse of modulo m, which is nothing but 1 raised to power a mod m, if I want to do something like this, I write the same thing as a raised to power m minus 2. Again, remember, this is not an like any modulo, it's a modulo with a prime number. So it's called as a Fermat-Little theorem. So what I can do is, if I know the factorial, again, there are two ways to solve this inverse of r factorial. One way is you keep on calculating the inverse of r factorial itself. What I mean by that is, factorial of n is nothing but n into factorial of n minus 1. That is one way. Similarly, let's say if you calculate the factorial of r. Again, how will you calculate it? Simply keep on, again, simply pre-compute this. Again, remember, you have to pre-compute this entire thing. You will pre-compute this entire thing. With this pre-computation of entire thing, you will have the factorial of every number, in which r will also be included because n is a bigger portion. I will pre-compute for all numbers. If I just go back and look at the constraints, okay. My laptop has got, and don't know what has happened to it, but this is kind of a glitching. It's not allowing me to change the screen. Okay, so what we will be doing is, okay, I cannot see the question itself because my laptop is, oh, I have reached. Okay, so what we will be doing is, we will simply see that my n is up till 1e5, so I can pre-compute for every values up till 1e5 factorial with modulo, make sure. Okay, that I can do, pre-compute that portion, and when this portion is done, I will have factorial of r also. So one way is, when I have a factorial of r, I just do a inverse modulo by saying my base, my a is factorial of r, which I have already computed. Just do a binary exponentiation and do a raised to power m minus 2 mod m, where a is this value, and you will get the inverse of the factorial of r. That is one way. Other way is, you just keep on, as you are building the factorial, you also keep on building the inverse of my factorial number. But I usually prefer to do via this way, which means get the factorial only, and in the log n operation, get the inverse of that factorial. Although if you don't want, you can just pre-compute that inverse factorial and you can just get rid of that log n operation also. Although it is entirely mathematical on how you approach it. But this problem was a very good explanation, like very good example of PnC, NCR, stars and bars, and the basic maths which is applied. So that's the reason this is a very good problem to judge your PnC skills, which includes stars and bars also. Now that is the entire thing which we have to do. Now one way is I go and write the entire code, but I have a preset with me. I'll use that preset instead. Although you can just like that preset is not very well structured, but still I have the entire NCR preset. So if I just write NCR, okay, that is not visible. Oh, that's a Java. Let me go and write NCR. So I'll show you, no worries. Okay, NCR, copy this and paste this. So there's nothing fancy going on here. Wait a second, I'll see where's my screen. Am I visible now? I am visible. So yeah, there's nothing fancy which is going on here. You will see that this is kind of a, what do you say, which I have written. template for my NCR calculation. Now, why specifically NCR? Because NCR will include everything. It will include modulo exponentiation, modulo multiplication, binary exponentiation, subtraction, addition, factorial, inverse. So I have just named this template by NCR itself. So if I just go back and show you guys, so this is how wait, how to show you. Okay, I have to go to the home screen. So now I'll show you. So this is how my template looks like. I just write NCR, right? I just click enter, and this is how my template looks like. It's not a very good template, as in fancy wise it might have some issues. I guess I remember, yeah, I wrote modulo inverse again, so it will give a comparison error. So yeah, I did not get time to change it, but this is, yeah, how the patterns look like. Now, as we saw, let's remove the modulo one of the operations. Which one to remove, this one or fast modulo should be above? Fast modulo should be above. Let's remove this one, top one. Okay, now as simple as that. We will have to do a simple few things, which means hash define ll as long int. So that is one basic thing which you cannot copy in a template. Now when this portion is done, you have the fast modulo, which will do a modulo b mod m. Now let's define also what is your mod m value, although you can pass that, but let's say let's have it as hash defined mod as 1 2 3 4 5 6 7 8 9. Now this mod is passed, so this will do a mod b, a raised power b mod m. This will do a x plus y mod m. This will do a x into y mod m. This will do a x minus y mod m. This will do a x upon y, which is nothing but x into inverse of y. Again, x into inverse, modulo inverse of y. And now modulo inverse is nothing but, oh sorry, this needs to be at the top, but above one was correct. It is nothing but in mod inverse, as you saw, x y raised power m, y raised power, like mod inverse of y with a mod m, saying the same thing, that I'll do mod inverse of, which is 1 upon a, like mod with m, it's nothing but a raised power m minus 2 mod m, right? So I get the divide also. Now I have this n as a fixed constant. For this question, I just need for 1e5. As you saw, it is 1e5. So I'll just go for 1e5. I also need this part. I can just do a 1e5 plus 5. I will have a factorial and the inverse factorial pre-computed. Now I'll just call this pre-compute function. So from my main function, I'll call this pre-compute function, just a simple calling of this function. Now this pre-compute will pre-compute my factorial and inverse factorial simultaneously. Now this firstly it will find the factorial, then it will find the inverse factorial by just simply doing a inverse of that specific factorial, as I showed you in the explanation also. Now when this portion is pre-computed, I can go and easily find my NCR. Now again, for this NCR, I just have to pass my n and r. Again, that's a simple case, n factorial into inverse of r factorial into inverse of m as r factorial, right? So I just have to go and find these values. So let's go and do our result. So as I showed you, I'll go on to all of this. N indicates I have these n number of children. I'll go on to all my 6 childs. Now starting off with my first child, I'll go on to all the rest of the childs. As you saw that for the first group, as you saw, I'll go on, as you saw previously also, for this first group, its impact was actually 0 itself, like 1 itself, like it will not increase the answer. So what I'll do is I'll start off from I equal to 1 and this is my I equal to 0. It is for the sick array, right? Okay, this is for the sick array. So I know one thing, that I will be from 1, I'll go up till the very end, which is nothing but my sick.size, and do a I++. Now when I am doing this, okay, this is a bit I'll just do a bit side, if this is okay. Yeah, this is okay. So cool. So what I'll do is I know that I will have to go on to all of my sick elements. I'll firstly have and find I'll do a group size. Now this group size will indicate my sick elements I should look at there. Okay. So for this, yeah, again, just make sure that you just comment down below anything whatsoever you have doubts or stuff, anything whatsoever, like Pratyush, I'll go into your comments for sure. But yeah, anything if you have just doubts, just let me know. So I just want to know the group size. So as you saw that if I just mark the indexes out, where the indexes, let's take this, take this example itself. So if this index is, because you will be given the indexes only 4 and 0 will be your input in the SIC array. So I want a group size which is 4 minus 0 minus 1. So I'll just do a SIC of I minus SIC of I minus 1 minus 1. It is a group size for me. Now for this group size, as we saw previously also, that we have our result. We will do simply one thing, multiply that thing again. Sorry, whenever you do multiplication stuff, do a mod. Now although I have a multiplication thing also, so I can just simply write this as a multiplication, but yeah, that's a basic multiplication, so that would not be nested, so I just don't use it. But yeah, I can just also write the same stuff as this stuff, mul my result with this next value which is going to be there, so I don't have to write anything else. Now again, this result is going to be multiplied with what? With the binary exponentiation of a raised to the power group size minus 1. So I'll just do the same thing. I know that I have to do a fast mode exponentiation of what? My group size. Oh, sorry, it is 2 raised power group size, 2 raised power group size, sorry, group size minus 1, right? With this, I'll get my result. But again, that is simply the pattern count which we had. Simply the pattern count. Again, your what if your SIC of I is 4, SIC of I minus 1 is 3, so 4 minus 3 is 1, minus 1 is a 0. Your group size is 0, which means you have no middle childs. Both the SIC people are already together. So this can give you a 0 minus 1, which is nothing but inverse, which is not possible. So let's have a bit condition, maximum of 0 comma group size minus 1. If that's okay. That seems fine. So with this, I've got my result, but now I have not yet consumed, or basically I should say I have not yet done the NCR, which means stars and bars stuff. So what I will do instead is I'll again have my result. Again, I'll just multiply my result with what? Now I have to multiply with the NCR value. Okay, we have very less watching, but no worries, you can still try. What we can do, we can just start off with this NCR value. Now this NCR, we will do simple NCR of what? Now my N is nothing but the total empty spaces so far, starting off with this SIC. So if I go on back, if I am at this SIC, I know I am at, let's rename this. It is 0 1 2 3 4 5 6 and 7. If I am at this specific index, my SIC of I is 7. I am at the index, if it is I is 0, I is actually 1. So I know I am at the index 1, my value is 7. I want to know the number of empty locations so far. You will see, with this index as 7, it means I have 8 elements. With this with this value of SIC as 7, I know I have 8 elements so far. With this index as 2, it just indicates, with this index as 1, it just indicates I have 2, the SIC people. So the empty, or basically non-SIC people so far would have been 8 minus 2. I can add the same thing as 7 minus 1, right, which is nothing but SIC of I minus I. SIC of I minus I, that is the number of empty, or basically the non-SIC people. So I just wanted the same thing. I just wanted the number of non-SIC peoples, which is SIC of I minus I, that is the number of non-SIC people. C, the group size. So I'll just do a C group size. With this, I'll get the NCR value also. Now when this portion is done, I have done the group size. Ultimately, you will see that you have, ultimately, if I go back, you have gone on to all of your group sizes, which means you have reached here. What if you still have some empty of the elements? So for the same stuff, what we will do is we will just have a like result in the end, which is nothing but multiplication of result, comma, again NCR. There is no of this thing because it is the ending group, so it will have only one pattern, which is multiplied by 1. For the ending part, again I should be knowing what is the total number of elements. So I know I have in total n elements. In that how many number of sick people were there? So it is nothing but sick dot size, right? Sick dot size. What the number of sick people I had in this entire thing? I had number of sick dot size people. Now what about the group size, end group size, which is the end group size? So my end group size is, okay, if I want to know my end group size, so if I have 8, 9, 10, 11, 12 and 13, I know my n is 14, right? I know that my n is 14, which is given. I know that I want to know this group size, so I should know that, okay, the last sick person was 10. So I know that, okay, last sick person was 10. So with this I will be getting 4, which is this 4, but I want 3 only as my last group size, so I'll do -1. So it is n minus last, which is sick of last value, which is sick dot back, which is this last value 10, -1 will give me the last group size. So I'll do the same thing. I'll do and say n minus sick dot back -1 is the last group size, and that's for sure only sufficient for me. Now ultimately return the result. Let's see if that works. Okay, we have to return the result. Okay, I'm returning result somewhere else. Let's return the result here itself. Cool. Yeah, we'll go into the comments soon if this does not get any error. 4.3, that seems fine. Let's judge it. It's running too late. TLE. Okay. So we are getting TLA because of maybe many operations which we were doing, which we can reduce depending upon, okay, we did the pre-computation, we are doing this inverse for every of those number, which is log n factor. That should not give us, but that sick is of size n. Okay, that is nothing but 1A5 and sorted in descending order. Maybe we are using everything as LL, so it would have been going a bit TLE. That is what I am guessing right now, but the basic approach will still remain the same. It's just the modulo. Again, I'm guessing the constraints are pretty tight for this and it needs everything. But I'm thinking, like, for sure, if I convert everything into integers and only use those, it will pass. But that's not a good practice. But for that, I have to modify the code a lot. Let's see if we can just think of something here and there to figure out that why it is exceeding the time limit. Okay, time limit, let's see. But yeah, the approach is still same. It's just that we have to optimize our code to do that's a login factor we are doing. Let's see. That is while b and a and b. That's correct. I'm doing the inverse for every of the factorial values. That's also correct. I have got the factorial values, inverse factorial. I have got the inverse factorial also. Now, when I have done the pre-computation in this portion, okay, seems like if this is failing the pre-computation itself, then that's a big headache. But I don't think it should fail in pre-computation because pre-computation is required. But maybe, yeah, it's log base 2. Oh, this does not count. Oh, again my laptop hanged. But cool. So like ultimately this is not the issue with our code. It's the issue with the strict time complexities, which because the code complexity is right now O of n log n, but that log n factor, I want to, but this is not scrolling up, but no worries. The things which we can apply, which we can try on doing is converting everything to int and only doing a casting to long when it is required. That is one modification which we will try if this thing goes away. Else, for sure, see, that has the most optimal approach. But yeah, we have seen that the problem setter put a very hard constraints on every problem, as we saw previously also. So just if you use the same approach, just modify your int, just modify your long to int and use your modulos very optimally, you will be able to solve it for sure. And yeah, that's pretty much it for you to solve this problem, which is not having to solve this. We can also go on to the approaches which people have on the discussion if this problem solves. But yeah, meanwhile we'll go on to the comments. If this solves, good. If not, then if anyone knows like why this happens in MacBook every time with me, I can have activity monitor. My RAM is okay, it's not that much used. Oh, I have Adobe Photoshop open. I'll quit this. Maybe this might help. It's taking a lot of memory. But yeah, that's done. Let's see if we have, yeah, we have done. So yeah, let's try to submit this up and we will replace everything with the LL. But for this, it's gonna be a very tough job because, okay, so let's copy this entire bad boy. No, don't reset. Let's copy this bad boy. Okay, let's copy this bad boy. Let's open this in the page where we can edit. So we'll go on to this. We will copy this bad boy here and we will now replace all the LL. We'll replace all the LL with the ints. Now when this replacement is done, I'll replace this and this and this and this and this. Have you seen Ranbir Kapoor's Animal movie? No bro, I didn't get time. But I'll replace everything with int. Okay, replacing everything with int. That's done. Cool. Now comes the interesting part. Now we will have to do modular at every step. This result, which is B right shift. Okay, this will actually work for int also, right? Just do a mod m. Okay, that is done. For here again do a mod m. For here do a mod m plus, okay, mod m. Okay, y mod m, and just do a result minus m. Okay, I'll do a mod m. I'm just doing mod m blindly at every step because I cannot afford to have a mod result remaining. X into y, return the result mod m. Again, this is mod m, this is mod m. Okay, subtract, just do a result plus mod m. Okay, that is mod m, that is mod m. Okay, that is mod m. Result plus m. Sorry, result plus m. Where is that gone? Oh, where is that gone? Okay, here it was. I'll do a result plus m mod m, and then here also I'll do a multiplication by this number mod m. I'll do factorial of this mod m of this mod number, that is true. Inverse factorial, again no need to be safe, just do a mod m, mod of this mod number. NCR, again we are doing the mod with p, that should be sufficient. Multiplication, let's run. Okay, maximum, no matcher action maximum. Okay, we have end group size, we have 0, we have maximum group size -1. What it wants, no matching function to call for maximum. Maximum of a constant 0. Shall I cast that to a int or what? Or what it wants? Int. Oh, sorry. Remove this. Okay, line 12, line 12, line 12, line 12, line 12. A into a mod m. Okay, that will overflow. What I can do is, if I do a mod m, still it will overflow. Okay, this can still overflow. So I need to have this value as long. I will convert this to a long int. Let's see now. Okay, runtime error 62 line. Where is that? Again, oh, this is multiplied by this number, then this can again flow to modulo. So what I can do is, I can just imagine these numbers as a LL. So I can just say 1 LL multiplied with this, and then it should not actually overflow. The same I have to do for this 1 LL multiplied with this factorial. Mod p ठीक है. Again this needs a 1 LL multiplied with this value. LG, I'm late. Will you be doing next problem after this? 4. This is the last problem. This is the last problem itself. We are just dealing with the absurd time complexity issues, and yeah, that is again the case. See, okay, let's see the solution, and that's exactly the same itself. It's just the more, for sure you have to just optimize something. See, it's the same approach which we took, 2 to the power maximum group of group size -1. Edit, it's the last question which we are doing right now. It's just that because of the strict time constraints, we had to optimize a few stuff, but the approach still being the same. Just finding the inverse, it's just finding the maybe factorial stuff. It is giving us a time complexity, because you can see the approach is still the same. I went on to all of my numbers and then did the same stuff as they are doing. It's just that we can see that the pattern to find here, you will see that to find this value exponent NCR, or basically NCK, they have factorial of n, factorial of k, multiply factorial of n minus k, inverse factorial. They have just, this is exactly same as what we have did, the inverse. To find out the inverse, they have done a bit kind of different, which means they are finding this pre-computation part in just specific time of O of n rather than O of n log n, which we are using O of n log n. So they are just finding the inverse of factorial and all that stuff. 1. Now he is saying that inverse of I-1 multiplied by the inverse of this existing factorial, which means inverse of I. It is just that saying inverse of I minus 1 into inverse of I itself, because if you are wanting to find the inverse factor of I itself, which is nothing but 1 by I, inverse of this modulo number, mod of this mod number I with this mod, inverse finding, and then mod minus mod by I multiplied by inverse of mod minus mod of I multiplied by mod. That is a great stuff to find the inverse, which you can remember. So what we were doing was we were finding the inverse in O of n log n, and this is how we can find inverse in O of n itself, which I never used, but yeah, that's one thing which we can use for sure. With this fact, we can achieve to get, but that is very absurd. If we are using a O of n log n, still it should work, but it is not. It still needs O of n as time complexity. That is a very absurd case, but no worries. Yeah, with this you can solve. But yeah, the main logic inside behind was entirely same. It's just that finding NCR, finding inverse, was a bit different. I don't know about your channel, but it's really interesting to watch how you are approaching the problem. Think that gives you a subscriber. Hope can make it to the next live before it starts. Sure. Every week for weekly contest we have live at 11 a.m. and for bi-weekly contest we have live at 11 p.m. Sometimes here and there we just have a bit 11:30 or 12ish, depending upon the issues. My MacBook crashes, but yeah, that was pretty much it. Yeah, the fourth question can be solved. It's just that the constraints are pretty high, so try to find the inverse also in O of n itself, while we are finding that in O of n log n. But while seeing the constraints, O of n log n should have worked, but again, this entire contest was a very hard on constraints. So yeah, that was pretty much it. If you guys liked it, then you can smash the like, baby. And we'll go to the comment of Pratyush. Bhai, I am currently in my 3rd year. Should I do CP and give contest, or should I do only LC, or should I start giving CF and CC contest? See, I'll recommend, I have been in the recruiting portion of when you recruit someone. What's that? Okay, so when you recruit someone, you have to go and figure out some questions. For example, if I am assigned as I have to interview someone, I will have to prepare a question bank. For me as an interviewer, I will look for the questions to ask the interviewer. Now, 95% of the people or the employees in the firm, they are not doing CP anymore. They can only understand or do Leetcode. That is how 95% of the employees are. And again, I am saying the same stuff for Google employees also. You might say that, okay, what if Google employees ask this? Even what if Goldman employees ask this? They can ask, in the rarest of the rare case, they can ask something which is out of the box, but that will for sure lie inside of your genre of Leetcode. Why I'm specifically focusing on Leetcode is the fact that there is a high chance that you might encounter the same question which you have seen before in an interview. Interview is a complete luck based system where a person will get a more leverage than you if he has seen the same problem. Me as an interviewer, I will have 10 problems prepared. I will ask these to all the candidates whosoever will come to me. But if you have prepared, let's say 8 out of these 10 problems, then this will give you a leverage instead, or rather than give you a leverage over the other folks who are interviewing. Thus, I say interview is very luck based, in which you should practice more so that you can cover all variety of problems. Now, the drawback on doing CF or CC, which means code forces and code shift, is that you will encounter same kind of ad hoc problems in the first 3 problems. And considering that you are still stuck at 4th question of Leetcode, or maybe the 3rd question, there's a high chance that you are only solving A, B and C and rarely D problem of a Div2 contest, which means you are only solving a A, B, C problem of a Div2 contest. And these problems A, B, C are ad hoc, sliding window, 2-pointer, DP, rarest of the rare case graphs. You will not encounter the broader genre of algorithms. That is the reason I say that if you have time constraints, if you have not done the LC before, if you have not tried for all kind of problems before, or basically when I say all kind of problems, if you have not been solving contest problems of LCs, or basically you have not solved the DSA 169 series, or basically any other series you can also pick, which means any other sheets you can also pick. 169 series is just lesser problems, wider variety. But yeah, still if you have not picked that, there's a high chance that if you encounter something new, you would not be able to solve it in a specific interview, I'm saying. So that's the reason. Just make sure. And now I'm also starting off with the most frequently asked questions by company tags in our Instagram. So we'll be starting off with the top 100 most frequently. Now in this sheets, we have seen the problems which will give the genre, but it's much better how you would feel if you have solved the same problem before. That is why we are starting off with top 100. Now when I say top 100, you will see that a problem in the last 6 months have been asked 36 times, 56 times, 40 times in a specific company. That is what we mean by top 100 most frequently asked questions. That will be a daily challenge for us, and that we'll be doing on our Instagram itself. So yeah, I'll say that if you have time, do code forces, code chef. That will make your mind a bit bigger and will open a bit more ad hoc problems kind of situations you will be able to solve. But if you are stuck, and if you specifically have very less time, let's say if you are a working professional, let's say if you are in a college and you have your internships round about the corner, or basically you have your placements, only you have just 1 year left on your placements and you have to prepare for all the companies, please, especially if you are in the 4th year, or if you are in the 3rd, like if you have your 3rd year started, you can maybe try CF and CC, you still have time. If you are in the 4th year, it's a big no. If you have not solved C's like code forces and stuff, please don't do it. Rather invest your time in Leetcode. I am saying this fact because I had done the same mistake. In all 4 years I did CF. Later I realized, while I was interviewing, I realized that I will pick the problems from code forces or code shift. No, I will not. I will pick the problems from Leetcode itself. And that is how everyone does. Even if I have done code forces, still I would not pick a problem from there itself, because that would not give me the entire like theory, examples, follow-ups, or anything like that. So you can still encounter a problem in an interview where you might have not seen that, or maybe you can just relate that from a code forces problem. That can happen if your interviewer is extremely far coder, maybe master or something, and also your previous interviews have been going well, or you have put a very high rating of code forces or code shift in your interview. In your resume, if you have put that specific thing, you will or you might be asked hard problems. See, I as an interviewer will get your resume, will get your all previous rounds like feedback, what you have got. Depending upon that feedback, what I have got from your previous round, I will ask you a follow-up question. Basically, I will ask you a question. Let's say if you have your previous round going very well, then I have the responsibility to ask you a hard question in this round. So it's not that I don't know what has been happening with you in the previous rounds. I know everything for every round. What was your feedback? And not only this, the first round itself is on the basis of your resume. So in your resume, if you have put master or basically candidate master, so for sure there can be a chance that he or the interviewer might ask you expert level question or basically candidate master level question. So that is how this everything goes off. Cool. So now you know that what you have to prepare. If you have time, do contest, give contest on Go for the Go Chef. That's great. If you don't have time, please don't waste your time and try to utilize your time as much as possible. Do more of questions which can cover everything, which is the DSA 169 series. Do more of questions which are more recently asked, because it's entirely luck based. I want you to cover more problems which have been asking. And for that, you can just go and check our Instagram, in which we actually will be starting off with the daily most frequently asked questions. And yeah, ultimately just practice more and more of LC if you don't have time. That's it. Cool. Aryan, if you become recruiter, please recruit me, yaar. Don't forget me. See, recruiter, we as a software developers don't become recruiters. We only become the interviewers. So yeah, I can become the interviewer, but I cannot become the recruiter. So yeah, that's it. Thank you, Bhaiya. Thank you, Ekansh. Valuable information. Cool. That was pretty much it for the live stream. It has been quite a lot of time. I see it has been a lot of time. Okay, we are a lot. It is 2:42. It has been the biggest live stream ever we had. But yeah, cool. I think that was a valuable session for you guys. I hope that you guys got the fourth question also. Thank you so much for watching. Again, before going, can you please smash that like maybe to 50 likes? That would be super great. Else, no worries. Thank you so much for watching. See you later. Goodbye. Take care. Bye bye. That is like, this camera just dies in 2 hours, so I knew one thing for sure, that this would die. But yeah, that was a really valuable contest, I should say. That actually, like, this was the best contest, kind of. Like, if we look off the constraints, it was actually good contest. But yeah, the constraints were pretty painful. Pretty painful. Cool. Thank you so much for watching. Bye-bye. Goodbye. Have a nice day. Masturbation. Cool. Bye-bye. Bye.